Good
Here
evening. My
comes
name is,
everyone. Axel,
yeah,
we'll just wait. Um,
let people join.
yeah, we've got 12 so far, 14,
Hmm.
18, 19. Thirty-four, 37. Lovely to see so many people coming in. Okay.
Are we ready to start? Okay. Well, good evening and welcome to tonight's webinar. Our presenter tonight is Richard Whitehead. He is the author of the book Why Tyrannosaurus, but Not If, the Dyslexic Blueprint for the Future of Education. He is a special needs assessor and former Senko. He's the principal trainer for Davis Learning Foundation in the UK, and he has delivered one-to-one Davis programs since 2002, over 20 years. Richard has presented on the Davis methods across 5 continents, and he's conducted webinars on multisensory learning for Operation Diversity, the University of Chester, and the SEND group. Richard's second book, which is the subject of tonight's webinar, Counting on Fingers, Why Some Bright and Creative People Struggle with Numbers and Mathematics and How That Can Be Changed, was published in October 2023. And I'll hand over to Richard to carry on.
Axel, thank you very much indeed. And thank you to both my colleagues, Axel and Marta, for being here this evening. I've been told that at the last minute, my Wi-Fi may be a little bit glitchy. So it seems that the flow of my speech is okay, unless you tell me otherwise, but that I might suddenly freeze. That wasn't real, by the way, but that I might suddenly freeze in terms of the video. I'm hoping that will be okay because largely what I'm going to be showing you is going to be on the screen. So we'll see how we go. And it's lovely to see so many of you here. And we're going to make a gentle start. So as Axel just told you, the subject of this evening's webinar. Oh, can I just very quickly check we are recording? That is fabulous. Okay. So as Axel just told you, the subject of this and I'm sure you know, the subject of this evening's webinar is Maths Makes Sense Now. We're going to be looking at dyslexia, dyscalculia, numeracy, and the Davis method. So Axel's already said a few words about me, which is great that I am indeed a former special educational needs coordinator. For my sins, I'm a linguist. I speak a few European languages. And I'm a Davis Dyslexia facilitator, trainer, and director of Davis UK and Ireland. And the Davis methods are based on Ron Davis's seminal book, The Gift of Dyslexia, Why Some of the Brightest People Can't Read and How They Can Learn. And there's a copy of my book that Axel mentioned earlier on, Why Tyrannosaurus But Not If. You can imagine we had to fight tooth and nail to get the domain whytyrannosaurusbutnotif.com. But the reason for that title, which will no doubt be the subject of another webinar, is how and why so many individuals struggle with little words in reading so that they can read longer words like Tyrannosaurus, but they'll make mistakes on common little words like if. So I'm therefore an author on dyslexia and dyscalculia, and there's my second book that Axel referred to, Counting on Fingers, which largely centers around the Davis Maths Mastery Program and also takes a fresh look at dyscalculia, which is a term that we're interested to know how many of you have come across. And I'm also a Davis Autism Approach facilitator and coach, which is another newer side of the Davis methods, which is extremely exciting. So now we'd like to hear a word about you, or to see a word about you. Marta is going to open up a poll, which essentially which will come up on your screens, and it will then just ask you a couple of questions about how did you find out about this webinar, first of all, and what brings you here. So whether you're here, out of personal interest, out of family interest, out of professional interest, or some combination of those, or none of the above. And so that will be really useful to us for us to get a sense of what's brought you all here this evening. So while we'll give you a moment to sort of start filling that in, and then I'll tell you a couple of other practical details about the webinar. Okay, thank you all so much. I can see that's being filled in by many of you. That's wonderful. Really helpful to us. So while you're filling that in, I want to tell you a little word about how this evening is going to be constructed. So the first part of this evening is, as you can see, is a formal webinar which is being recorded. So you will only be seeing on the screen myself, possibly my colleagues Axel and Marta. You won't be seeing yourselves. So those of you attending cannot be seen or heard. You will be able to ask questions, which I'll talk about in a moment. Okay. But your questions will be, while we're in the formal webinar, they would have to be typed questions. Okay. In fact, what I'll do, I'll just pop out of the presentation for a moment to sort of show you how that side of things works. So if you look down to the bottom of your Zoom panel, you will probably be able to see you'll probably be able to see not sure what you can see actually, but you'll be able to see a kind of a speech bubble that says chat. And you will also see a double speech bubble that says Q&A. Okay. Essentially, the single speech bubble, the chat, is for gossip. So if you want to talk among yourselves about how awful my hairstyle is, or the color of my jacket, or how you're finding this evening, or just any chit chat about dyscalculia and so on, or maths difficulties, you can do that in there. And Axel and Marta will be dropping some kind of casual questions into the chat as the evening goes on, in order to see if you want to start a conversation there. But chat is just for casual conversation. Okay, the Q&A, the double speech bubble that says Q&A, that is where we want you to post questions that you want us to answer at the end of the webinar, of the presentation part of the webinar. Okay, so if you want an answer in the webinar to something, put the question in Q&A. All right, and then we'll work through those questions in the latter part of the webinar, give answers to them, and that's how that will work. So chat is for informal gossip and chit chat. Q&A is for questions that you want to be answered in the webinar. Hoping that's all okay. And if you'd like to say hi in the chat now, yeah, it would be lovely if any of you want to say hi. Yeah, I'm seeing a few people saying hi. Anything you want to say about where you're joining from is always interesting. It would be lovely to see what our geographical spread is this evening. From Canada, we've got somebody. That's wonderful. London, and yeah, okay, we've got quite a range. South Africa, France. Again, South Africa, Tennessee. Wonderful. Okay, so we've got a real spread. Last time we had a participant from India who was very, very nobly staying up into the depths of the night in order to be on the webinar. Lovely to see such a spread. Okay, so the other important thing that we want you to know is this. if you think back to the olden days where we would have given presentations perhaps in lecture theatres, perhaps in church halls, and so on, yeah, you would have had a structure to the evening where you would have been sitting and listening to the presenter. At the end, then maybe putting your hand up and asking questions. But then after that, there would have been perhaps coffee and mingling. And then the presenter would have come down and had, informal chit chat with you all. Okay. And that's something that we've missed since moving over to more of a webinar format. So here's what we do. Here's what we're going to do. After the webinar itself, we will close the webinar and we will open up another Zoom meeting, which we're calling a virtual coffee meeting. So some of you may have been at past webinars and experienced this. Again, feel free to chat and say you've experienced this if you have before. But the virtual coffee meeting is an ordinary Zoom meeting, a kind of a common garden Zoom meeting, where you'll come in, that won't be recorded, but we would ask you to be on camera and on mic. Okay, so if you want to have kind of informal, face-to-face chat, as it were, after the webinar, then you're very welcome to join us on that link. And I'm going to drop that link into the chat now. Okay, so what that is, that's actually a page on our website. And when you go to that page, there's then a button that you can click. When you click that button, it opens up the Zoom meeting. Okay, so don't do that now. Please stay here now. But at the end of the webinar, I'll drop that link in again. And those of you who want to stay on for half an hour for just an actual real chat, then I'll be there, my colleagues will be there, and it'll be lovely to see as many of you there as would like to attend, would like to be there. Okay, so here we go. Dyscalculia. Interesting as to in the chat how many of you are saying that you've heard of dyscalculia. Okay, do post in the chat. Feel free to post in the chat whether you have heard the term dyscalculia or not. We're really curious about that. We've got a yes. Okay. The reason why we're asking that question is because dyscalculia is very much dyslexia's poor cousin. Okay. While the term dyslexia is widely known, talked about, and increasingly celebrated for the talents that accompany it, comparatively few of us have heard of kind of maths dyslexia, as it were, which is formally known as dyscalculia. Okay, but also it's not as straightforward as that, because under current UK guidance, at least, problems with mathematics don't automatically make you dyscalculic. There's an organization in the UK called SASC, which stands for SPLD Assessment Standards Committee. The initials within the initials, which are SPLD, stand for specific learning difficulties. And SASC identifies 3 categories of mathematical learning difficulties. The first of those is dyscalculia, an SPLD, a specific learning difficulty, whose core feature is a problem with the sense of number. But there can also be other specific learning difficulties which do not include a problem with sense of number, but which may have an impact on mathematics learning. And then there's also maths learning difficulties arising from a lack of appropriate teaching, from environmental factors, or from medical conditions. Okay. Now, according to the British Dyslexia Association, dyscalculia is a specific and persistent difficulty in understanding numbers and is distinguishable from other maths issues due to the severity of difficulties with number sense, including subitizing, I'll come back to that in a moment, symbolic and non-symbolic magnitude comparison, and ordering. Okay. Now, subitizing is the ability to see a small quantity and immediately know what that quantity is. So you see like 5 as displayed on a die, you're playing dice, and you know that it's 5 without having to count it up. Okay. But what's interesting here is that from the BDA is talking about a specific and persistent difficulty in understanding numbers. Okay. That means that from the BDA's perspective, dyscalculic difficulties should be difficult to resolve. Okay. Yet, in my experience, these persistent difficulties can be resolved quickly. Here is a message that was sent to me a couple of years ago now by the mother of a then 12-year-old boy diagnosed with dyscalculia in March 2022, who took a Davis Maths Mastery program with me in April 2022, the month afterwards. And following his Davis program in May and early June 2022, he sat and passed the common entrance examinations in maths. And I should point out he had failed his mock examinations for common entrance at the end of January 2022, obtaining a result of 22%. In the exams he took in May and early June, he passed, obtaining 65%. And that was just 1 month after his Davis Maths Mastery program. And his mother wrote to me when the results came out, and she said, Mrs. T, who's R's maths teacher, was hugely complimentary about your work with R and quite emotional about his common entrance result today, as was his science teacher, who noted the dramatic improvement in R's ability after your sessions, because maths affects science as well. R is the only non-scholarship student to win the Headmaster's Academic Endeavour Award. Your ears must be constantly burning with the amount of times I sing your praises to everyone. Okay. So in mathematics, there is what we call a problem hierarchy. Okay. Let's think, what is going on? We need to think about what is going on when dyscalculic picture thinkers struggle with maths. It's important here to recognize that maths is not one single skill. Rather, it is a hierarchy of skills that build one on top of another. And a problem anywhere in that hierarchy can affect performance in any or all of the layers above it, whether or not that layer itself is problematic. Okay? So I'm going to display this as a kind of an inverted pyramid on the screen. And at the top, which is the most visible level, we see operational skill. Problems here lead to what we would call mistakes. To solve a maths problem, you usually need to perform a series of operations accurately and in a particular sequence. Going a layer down from that, at the core of mathematical operations almost always lies arithmetic. If you don't clearly understand what it means to add, subtract, multiply, and divide, you will at best develop a glitchy form of memorization that will quickly fail you as soon as mathematical operations become more complex. Moving down to the next level, to be able to perform arithmetic successfully, you need a clear sense of number. Before you can add or subtract, you need to be able to count fluently, forwards and backwards, without losing count or making mistakes. So far, so good. But at the very bottom come two layers that many mathematical interventions fail to recognize. In order to engage with mathematics at any level at all, you need to be able to think like a mathematician. And thinking is not one single function. Rather, we think in different ways at different times, depending on purpose and circumstance. And success in mathematics requires a particular way of thinking that is sequential, deductive, consistent, and rooted in the notion of cause and effect. Down to the bottom layer, in order to think like a mathematician, your focus on the problem being solved needs to remain consistent from start to finish. It's no good to start a mathematical problem and then we get distracted by what we're going to cook for dinner, by the squirrel climbing the tree outside, by the fact that it's our best friend's birthday and I haven't sent them a card yet, and so on and so forth. And And then, okay, where were we? So your focus needs to remain consistent from start to finish in the mathematical task, because any hiccups in your focus can compromise not only your accuracy, but also the consistency of your mathematical thinking as you're solving the problem. I'm hoping this makes sense. Do drop into the chat a kind of a yes or not sure or whatever, if if you want to comment as we're going along. Okay. So let's start with focus. In some models, restrictions on what's called working memory correlate with restrictions on attention stamina. But here's the thing about focus. Imagine a teacher or a parent telling a child to pay attention. And then the child responds by asking, how? Most teachers and parents would be taken aback by this question, and they wouldn't find a ready response. In all Davis programs, the starting point is a suite of mental self-management tools, collectively known as the Davis orientation tools. These tools develop accurate perception, a relaxed and consistent state of focus, and an awareness of your energy levels and how to align them optimally to the task in hand. In a real sense, these Davis tools are the answer to that child's question, how do I pay attention? So once a person has a conscious set of focusing tools, we can go about helping them enhance their mathematical thinking. In a Davis program, we do this by exploring a set of key concepts that lie at the core of our ability to think mathematically. To understand and to solve even the simplest of mathematical equations, like 1 + 1 = 2, you need to have mastered a hierarchy of concepts that starts with the idea of change. Okay. Here, 1 is becoming 2, which is a form of change. Then it explores how and why change happens, namely through the idea of consequence or causality, which can be broken down into cause and effect, or into before and after, or both. Adding 1 to another 1 is a cause that produces the effect of 2. And again, let us know in the chat if this is making sense, or if it is not making sense. Great, we're getting some make sense coming through. That's brilliant. Okay, so does this make sense? That if we look at 1 + 1 = 2, and we ask the question, why do we have 2, or how did 2 happen? It's because 1 was added to 1. So even at this basic level of mathematical equations, we have 1 added to 1 as a cause and 2 as an effect. Okay. Akin to time, we need to be consistent and even in the way that we measure a change in quantity. Solving a maths equation requires an understanding of the sequence in which the necessary changes occur. And to work accurately, we need to create and stick to rules and systems, such as place value, which could be described as order. So in a Davis program, what we do is using the plasticine clay, we work through each of these core concepts that you're seeing in the purple on the screen, where the individual makes their own clay model representing each of these concepts. Then we go and explore in the environment to find as many examples as possible of each of the concepts we're looking at. So if we're making consequence, a person might come up with a model such as the one you see on the screen. For example, here you can see there's somebody pushing a row of dominoes, and then there's an arrow, and on the other side we have fallen dominoes. So we've got cause, pushing dominoes, effect, fallen dominoes. That becomes a simple little mental template that then when we go outside and we see an acorn falling off a tree because a squirrel jumped on it, or we see inside a tap turned on because I turned it, yeah, or the door of the car shut because somebody pushed it, and so on and so forth. We can start processing everything that we're seeing in the world through the filter of that concept. So it's a very simple, very enjoyable, very fun process that just sets up, ensures that everybody that we're working with has these little thinking tools of change, consequence, cause, effect, before, after, time, sequence, order versus disorder, before we move on into actual mathematics. Okay, here's an example of a model for time. And often difficulties with mathematics go hand in hand with difficulties with time awareness. If you've noticed that in people that you know who have maths difficulties, please you can drop that into the chat. Okay, many individuals, or if not most or all, who have difficulties with mathematics also have difficulties with time awareness, telling the time and or estimating how much time is passing. So here's a model made in a Davis program where time is explored as the way we measure change. Okay, time is when we decide we want to measure how long between a before and an after. Yeah, we would use a calendar or a clock to do so. I have a wristwatch on at the moment, but my wristwatch is not a random thing that I made in my garage. It counts time in exactly the same way as everybody else's wristwatch, clock, and timepiece. Why? Because it's based on a standard, which is the Earth rotating on its axis. And so here we have a model that's depicting, in this case, the year standard, where we have an egg turning into a chick, and that's being measured using a calendar. We have the person's depiction of themselves in the model as well. And we're seeing then an Earth, proportions are quite interesting here, but we've got the Earth rotating or orbiting around the sun while rotating on its axis, which is essentially the year standard. It's how the calendar works. Okay, and it's how the seasons occur. Okay, just as a little aside, a couple of years ago, I worked with an 11-year-old boy on this concept of time. And when we work with time in a Davis program, we also get very interactive. We usually use a globe. We shine a torch on the globe. We darken the room. We start spinning the globe in order then to be able to look at, here's a piece of plasticine on India, actually. But we put a piece of plasticine on where we are. We spin the globe and we start exploring, how day and night works. Okay, so if the torch is over here, this would be midday. This would be the evening. This would be midnight. This would be early morning for these people, and so on. And this 11-year-old boy I worked with, immediately after mastering time in the program with the globe and the torch, and then we went out and we did lots of experiments. We timed each other using stopwatches. We set up a sundial in the window in order to see how the shadow would move in the course of what we were doing. He then went on holiday, and when he came back from holiday, his mother told me, by the way, you ruined our holiday, Richard. And it was said in jest, but whereas this boy in the past would have kind of been just gently in the now, without much awareness of time passing, until then at the end of the holiday, it would be time to go to the airport. Oh, okay. Now he was saying, Mum, we've got 3 days left. What are we going to do in those 3 days? Mum, we've got 2 days left. Mum, it's only 7 hours till we need to go to the airport. And so he had this sort of timer going on, and this was instant. This was immediately after mastering time in a Davis program. It was like a switch was thrown, and now he could see time and how it worked. Okay, so that's incidental to the mathematical side of things, but because the two very often go hand in hand, you can see how it's how important it is to kind of enable a person to throw these switches one after another, because each of these is a little piece of your mathematical thinking that you need to develop before you can even start to do any mathematics, because any mathematics you do without those pieces is going to be at best just kind of rote learned, kind of memory trick stuff. And that's not what we're after in a Davis program. We're after mathematical fluency, which is based on a real understanding of what's going on. Okay. Once mathematical thinking has been established through the Davis concept mastery process, we can explore a person's awareness of number. Counting requires consistency of focus on a sequence of numbers that are either increasing or decreasing by 1 each time. And quite commonly, I encounter kind of glitching. In Davis, we call this disorientation. When a person is asked to count backwards, especially in the teen numbers or across a 10 boundary. So making number sequences out of clay and using the Davis orientation tools while counting forwards and backwards will generally resolve these disorientations and establish accuracy and consistency of counting both forwards and backwards. Okay. Once number awareness and counting have been established, we can move into exploring arithmetic, operations such as adding, subtracting, then multiplying, and finally dividing. Initially, plasticine clay is used again here as a way of experiencing what is happening to the real quantities when you do arithmetic. So often I do this with clients in a way that combines place value and mental arithmetic. In this example here, we see 23 plus 34. At the top, I don't know if you can see that you've got top left, you've got a couple of kind of clusters of balls. There are actually 10 balls in each of those clusters. Okay, so essentially, top left, you've got 2 10s. Okay, and top right, you've got 3 1s, 3 units, individual balls. And at the bottom, we've got 3 10s and 4 units that are kind of there in that holding area, ready to be added in. Now, what is adding? Adding is putting one quantity with another quantity. So when we add for real, that's what we're doing. To perform the addition, you just need to move the quantities from the bottom up to the top so that they're together with the other quantity. Normally, my clients do this. Here, we're just seeing me demonstrating the process on Zoom. And it then becomes very easy to see the answer. 57, right? When a client performs operations of this kind multiple times, eventually it becomes easy to visualize the operation without actually doing it. You can see this on a mental screen and run it as a mental movie. And that's what we call mental arithmetic. When you can picture it and you can perform the operation in your imagination, you're doing mental arithmetic, which is something that very often our clients have never actually done before they come to us. It gets interesting, however, when the number of units added together goes above 10. So here we have 18 plus 13. Now, what's going to happen when we put those together? The result in the top right quadrant is something that in Davis we call disorder, which is one of the mathematical concepts we've been looking at in the clay earlier. Okay. Disorder is when things are not in their proper place, position, and or condition. Top right is disorder because there are too many balls there, because we do not have, in the language of mathematics, a single numeral that describes any quantity greater than 9, right? 9 is where the numerals stop. So what do we have to do to create order? Well, we can form a 10 and move it across to the tens place. And then we can see the answer. Subtraction, by the way, can be explored in a very similar way. It's essentially by just running the same process in reverse. Now, multiplying. Multiplying is essentially just adding in groups. Here we see a creative model that shows 3 samosas at a time dropping off a conveyor belt into a packing box. Once 3 has been added to nothing, put in an empty box 2 times, we have 6. And that is multiplication. Then we have 9, then we have 12, and so on. So this is just a way that a client used to model the idea of multiplication in order to then have a picture of what it meant when they started doing it. So multiplication is repeated adding in groups. It can be explored using a 2-dimensional ball grid. Here, we see that we can't see it terribly well, but 3 times 4 equals 12. A little bit clearer here. I think you'll be able to see 8 times 3 equals 24. Now, if I just activate my pointer, we can see if you were to count the balls here, you would see that there are 8 balls going up this way. There are 3 balls going this way. In here, there are 24 balls. And if you don't believe me, you can count them. So we have a kind of a real times table here where you never need to guess or memorize. If you don't know the answer, you can just count. And over time, you might then start finding other creative ways of figuring how many are here. For example, if you know that there are 30 here, and of those 30, there are 6 here, and through the other exercises I just showed, your subtraction has got good enough for you to know that 30 minus 6 equals 24, then that's another way that you can get to that being 24. So you can start to use your own natural dyslexic, dyscalculic creativity in order to explore the quantities and find out what's going on. Okay, you get to experience the timetables for real until you reach certainty. Then later, the same grid can be used to explore division. So you can use it the same thing in order to see that 24, this amount here, divided by 3 equals what's left? 8. Yeah, it's the same process. It's just that we have a different starting point. Plasticine balls can be used to explore place value. So here we have 11. Why do we have, is 11 written as 1 and another 1? Because the 1 on the left is in the place where the 1 is counting tens, and there's 1 10. The 1 on the right is in the place where we're counting units, and there's 1 unit. And you can expand that principle and move on into decimals. So here we're seeing 111.111, and we've even taken the trouble together with our client to make 100, 100 on the left, okay? And then you can see actually a sequence of how it's getting smaller and smaller as you move to the right, okay? And then once you get past the decimal point, the 10th is formed by rolling up a ball, so rolling a ball into a kind of a sausage or a rope and then cutting it into 10 pieces. You take one of those pieces and you place it on the table, and it's 0.1 or a 10th. Then you can take another one of those tenths, roll that into a rope, cut that into 10 pieces, take one of those pieces, place it to the right, and you have 0.01 or a hundredth. And believe it or not, we keep going with this as far as thousandths. You can possibly through a microscope see the tiny little thousandth at the end of this sequence here. And then you can see that one of those tiny little specks, what it would take 100,000 of those tiny little specks to make the 100 that you see on the left. Okay. So once the reality of all the basic arithmetical functions and the place value system has been thoroughly explored, we can progress to doing maths on paper. Generally, I find that my clients do this with remarkable ease once they've become confident at mental arithmetic through the plasticine work. Here you see an example of some multiplication work from a maths program that I delivered online to a then 10-year-old boy during the pandemic. As we were working online, I created a form of graph paper in Microsoft Word, and my client worked on it while showing it to me across Zoom screen share. Working in Word, he typed the numerals and arithmetic symbols, but he used the draw function for the lines and the decimal points. So what you see here is all his own work. A 10-year-old boy who had barely any number sense before we started the process. Now, sorry, this is slightly wrong order. But one of the things that plagues many mathematical thinkers or many individuals with mathematical difficulties is the so-called maths word problems or maths story problems. You know, the kind of, Gina and Fred are digging a swimming pool. Their buckets will carry so much rubble and so on and so forth. Or Zainab needs to go to catch a bus at 3:10. It takes her 25 minutes to walk to the bus stop. What time does she need to leave home? All of those sorts of things with increasing difficulty. So what we find with these is that it's all about picturing them. And we have a process in Davis called picture at punctuation, which I talked about in my previous webinar when we were looking at exam success for picture thinkers. And in picture punctuation, you essentially stop at each punctuation mark and see if you can make a mental image of what you just read. That works extremely well in fictional writing, and with a bit of training also in factual kind of textbook type writing. When we're dealing with mathematics, it can sometimes be helpful to draw your picture, because the thing about a math story problem is you need to accurately capture every detail of what's being said. And at least while you're getting used to the process of solving these, it can be helpful to draw them so that you can capture each detail as you're going along and then look at your picture. And the key is always to figure out what mathematics you need to do in order to solve the problem. So here we have a word problem. Paco took off in his helicopter from 400 meters above sea level. He later landed at a location 500 meters above sea level. What was Paco's change in altitude? When you draw it out, you can then see that essentially what you're needing to do is subtraction. So you need to be able to see this one, subtract this one from it, and then the difference is the change in altitude. But take a look at this word here, from. Okay, this is an example in Davis of what we call a trigger word. And we will do separate webinars on this, but this is the conundrum, the problem that I talk about in my first book, Why Tyrannosaurus But Not If. These small abstract words will very often throw somebody. Okay, and when you're doing mathematical story problems, some of these words have a particular meaning. Look at the difference here between took off in his helicopter. You know, he's surrounded by the frame of his helicopter. He's inside it, as compared to change in altitude. It's a different meaning of in, right? And that second in has a more mathematical meaning. And that if you are a picture thinker, so you're blanking on these words anyway, and also your mathematical ability is just starting to blossom through what we're doing, you will have a problem with these words. So we have, I don't have a slide for this, but we have a clay-based process in a Davis Maths Mastery program where these words in their mathematical meaning are made in clay, so that then when you're doing the math story problem, you're not going to be tripped up by misreading or misunderstanding these little words as you're going along. Okay. Now, although not part of a Davis Maths Mastery program, some of us facilitators get kind of excited towards the end of the process, and we add in bespoke elements from more advanced mathematics for our older clients. Here, for example, is a creative way of seeing how to expand brackets in an algebraic formula. So what we did was the task in hand was to take 3x plus 2 in brackets times 5. We went down to the kitchen and got a load of spoons because we needed something that wasn't the clay balls to represent a kind of an unknown quantity, which is x. And I don't know if you can see that we have a row where we've got 3 spoons and 2 ones. Balls in Davis represent 1. Okay, so we've got one row of 3x plus 2, another row of 3x plus 2, and so on until we've got 5 rows of 3x plus 2. Then we can solve this by just counting up the spoons and counting up the balls. Okay, and what we see again and again is by doing one example of a particular mathematical operation in the clay, or in this kind of multisensory way, the creative picture thinking individuals that we work with, they'll very quickly then be able to apply that picture, that experience, to other examples. So you could then take a whole page of this sort of thing, and suddenly the person's able to do it because the picture of what's going on has been switched on through the multisensory work that we've been doing, if that makes sense. Using clay to explore volume is great because you can go into 3D. So with this client, after exploring area on graph paper in 2D, this client then made some cubic centimeters out of clay, stacked them, and explored how and why 2 cubed is 8. Because we've got 2 this way, 2 this way, 2 going up, and then if you count the cubes, you've got 8. And again, it's enough typically to do this once, and then it switches on the principle for the person, and then they can go back to paper in order to, to perform these operations successfully. Here's an example shared by my colleague Yelena Nikulina, which is showing why 2 divided by 3 makes 2/3. And here's an example from algebra. In counting on fingers, I have a whole, in my second book, I have a whole sequence of how I sometimes work with people as a kind of an introduction to algebra. Now, in order to do algebra successfully, you need to be able to make changes to the problem that don't affect the amounts or the outcome. Okay? And so we have a series of operations that we will do using a set of scales to represent the idea of equals. When the scales balance, you have the same amount on both sides, which can symbolize the idea of equals. Okay? We determine initially what will represent 1. So here we have these little, like old-fashioned 1-ounce scale weights. And we talk to one of these and say, you represent 1. Okay, and then we make a whole load of them. Okay, then we make something that isn't 1, but we don't really know what it is, just some random object, which can represent an unknown quantity, which in algebra would be expressed as a letter. Here we've got 2 sausages. And so then it can be like, okay, well, rather than bothering to write out the word sausage, why don't we just write S? So rather than 2 sausages, we're going to say 2S. But we've also got a rogue 1 on this side of the scales. So we haven't just got 2S, we've got 2S plus 1. On this side, we've got 5. Now, this would be about stage 5 of a process that I do that we build up to, okay? But once we get to this stage, what we're exploring and what we've figured, we know that we have to do is we've got to make a change to the scales that still keeps them in balance. So imagine there's a stink bomb in the fulcrum in the middle of the scales, and if it goes out of balance, it's going to go off and stink the kitchen out, okay? How are we going to make a change that keeps the scales in balance? Well, the first thing we could do is take this one off and this one off at the same time. If we take one off both sides, the scales will stay in balance. And I find that my clients do this intuitively. It's kind of, when you see it in the real world, it's a no-brainer, okay? Once we've done that, we'll be left with just 2 sausages here and 4 ones here, okay? Then, how can we get rid of 1 sausage? Well, that's half of what's left on here, so we take half of what's left here, okay? So 4 goes down to 2, and then we see the answer, which is S equals 2. So that was a slightly kind of express tour of how we do this, but using this principle, you can explore the various changes that you can make to an algebraic equation in order to simplify it. You can add the same amount to both sides. You can subtract the same amount from both sides. You can multiply both sides by the same amount, or you can divide both sides by the same amount. And you do a sequence of those things until you've just got one thing here, one unknown, and then it's no longer unknown. Here you can see what it is. And again, what I find is once we've done a short sequence of steps with this, you can take a kind of an early key stage 3 type sheet of algebra problems of this sort of level and the person will solve them one after another, and they'll all be correct because the person has now got a mental picture in order to guide them through what's expected of them, what's the meaning of what they're doing, what they're being asked to do. Here's another one, quadratic formulae. Okay, so I don't know if you can see here, but if you what we have is strips representing x. So each of these strips is x long. X just means long here means we haven't measured it. We don't know how long it is. It's unknown, okay? And it's 1 wide. So this is an x. When it's x long and x wide, it's x squared. So sometimes before doing this, we need to explore principles of geometry and why the area of a square is the length times the width, likewise a rectangle, okay? And I have a script for that in Counting in Fingers in my book as well, okay? But once you've explored that, which you can also do in a clay-based multisensory way, then we can set up something like this. And if you were an ant walking from here along here, how far would you walk? Sorry, let's start with the top one. Yep. You're walking up here, you would walk. Now I've walked, now I've walked x long, and I'm going to walk 1, and another one, and another one. So I've walked x plus 3. Okay. Another ant walking this way is going to walk x long plus 1 plus another one, x plus 2. Okay. The area of a rectangle is the length times the width. Okay. So which could be expressed here as x plus 3 times x plus 2. Okay, and if you're being asked to multiply out the brackets, the answer is actually what you see here. X squared plus 5x, 1, 2, 3, 4, 5, plus 6 ones. Okay, and then you can see visually how that works. You can also see why it's called a quadratic formula. Okay, as in square or rectangle. And again, what we find is that there are word-based or traditional ways of doing this, such as the FOIL acronym, front, outside, inside, last. But in order to make sure that FOIL isn't just a memorized trick, you've now got a picture behind what you're doing in the operation. So you have a backdrop of meaning that then is going to guide you. And again, we then find that the people that we're working with, they move on to being confident and fluent. Now, I am in trepidation now because I want to finish by showing you a really funky example, which we might see. I'm going to risk it. Some of you might find this a little bit confusing. Some of you might be able to see what's going on here. Okay, so I'm going to show you this. This is an example from Key Stage 4. Okay, so this was a UK Year 11 client who came to me, who said, I've got to do function notation. Okay, and I don't understand what's going on here. Okay, and so what she had to look at was y equals f in brackets x minus 3 minus sorry, this isn't actually exactly what it was. I don't know why it got changed, but it's a function notation lesson. What it was y equals f x minus 3 in brackets minus 3. Okay, so the principle that we're looking at here is that you're dealing with a function where you don't know what the function is. The function could be anything. Okay, and then that gets plotted on a graph, what the different possibilities are. So we watched a video that had been prepared by this client's maths teacher, which was on her kind of learning platform. And then we figured out, well, what's going on here is we have an unknown, an x, and she made a kind of a little shellfish to represent that. Okay. And then what happens to that x? Well, the x gets 3 sucked out of it. It goes onto a conveyor belt. We put the x onto a conveyor belt, and these evil people, they suck 3 ones out of the x. So as it carries on along the conveyor belt, it isn't x anymore, it's x minus 3. Then that x minus 3 goes into a closed f box where it gets f'd. Okay, so some sort of function, we don't know what it is, happens to the x minus 3 inside of that box. Can you see here? We've got function of x minus 3. Okay, then that functionified x minus 3, whatever monster that now is, comes out of the box into a, we can't now see what it is. So it's in a tunnel because we don't know what's been done to it. And then another 3 gets sucked out of it, minus 3. And then it carries on. And at the end, it falls into a Y basket. Okay. So what do we have in the Y basket? We've got x minus 3, which has been f'd, and then another minus 3, another 3 taken out of it. Okay, so this was perhaps the most advanced sort of mathematical thing that I've ever tried to do with someone in the clay. And that person, who's now, I think, 22, says that she still remembers it. And that then going back into class, she was able to start to solve some of these things because she had, once again, a picture behind it. Okay, so what sort of things do people say about the Davis Maths Mastery Program? So this is the, if you remember the boy, the 10-year-old boy whose maths workings I put up on the screen earlier on the kind of the grid paper, his mother said, the Davis Maths Mastery course matched the pace my child needed to learn. I witnessed my son grasp concepts with speed and clarity, growing in confidence and excitement to learn more. Maths very quickly became his favorite subject. We were both blown away by how quickly years of lost learning were set in a foundation which became easy to build upon. And the last sentence is my most favorite thing anyone's ever said to me, I think. He can't remember the time he did not understand maths. The father of a girl I worked with, who was 12 when I worked with her, said after G was diagnosed with dyscalculia, her school continued to teach her in the same way, and she struggled along. She also had additional maths on a Saturday morning. Whilst this certainly helped, we kept looking for alternatives and discovered the Davis technique. At first, we were skeptical as to how there could be a link to clay modeling and solving maths. At the end of the program, however, I'm convinced that this has had the single most significant benefit to G's learning of both maths and other subjects. The combinations of the technique and the patient delivery removed her fear of maths and showed how it could be done. What you gave her was the ability to see maths and lose the fear of it. Okay. So, we'll open up for questions in a moment. Okay. One thing I just want to sort of put out there is that anytime we would love to hear from you, and we would love to, we have a team of expert facilitators who would love to conduct a free 30-minute consultation call with you in order to explore one-to-one what would be the right solution for you or your child. Okay. We're very aware this is a dry webinar where you're all off camera. We're going to have a chance to chat, hopefully, in a coffee meeting fairly soon after this. But we'd also love to be able to chat with you one-to-one in order to really drill down into what's happening for you or what's happening for your child or your pupil or pupils, and whether the Davis approach perhaps could help, and if so, what would be our kind of tailored suggestion to you as to how you could get things started with us, if you would like that. Okay, so feel free to request that. We're going to take questions, and while we do so, we're going to put a poll up, another poll up on the screen, where we're going to be asking you to tell us what you thought of the webinar so far this evening. Yeah, the formal part of the webinar. Okay, and there's also an opportunity to use that form in order to request a consultation from us, if you would like to do that. As I said, it's completely free. If you feel moved to, to pick up, have the phone picked up and be spoken to, we would really, really love to hear from you. If you do say yes, that you would like a consultation, it would be really, really helpful to have your phone number. Otherwise, then, email isn't always the most efficient route to get immediately in touch. If you do that, then that will expedite things, and one of us will be in touch really soon. Okay, so I think we've got a few questions accumulating in the chat. So, how do you overcome digit reversals? Now, that's a really interesting one. Maybe I'll just put up on the screen one of the slides that we had earlier, because then I can show you the answer to this. Just find the right one. Yeah, okay. So here you see a clay, the clay-based process for mastering counting. What we have here is the real quantities at the top, the real numbers, okay, as meaning the amounts of balls. Underneath, we have the numeral symbols, the digits. So these are the things that are going to get reversed if they're going to get reversed, right? If a person is reversing numerals, it's because at some point when they were learning them, they were confused. They were confused enough to do what in Davis we call disorientate. When you disorientate, in the Davis meaning of the word, you start to experience a kind of an alternate reality. Your mind goes into creative mode and it starts to experience not what's actually there, but what it's creating. You can experience something similar if you're in a vehicle that's stationary and next to you there's another vehicle that moves off and you feel like you're moving backwards. Sitting in a train at the station, you're looking out the window, another train moves off, you feel like you're really moving. Okay, so that would be an example of disorientation. Some of those optical illusions that you can see with these kind of spirals, and they seem to be moving. It's the same thing. It seems like it's reality at the moment that it's happening. And if you're confused, disorientation is typically triggered. One of the main triggers of disorientation is confusion. Okay, if you're being taught something and you're confused and you're naturally creative thinker, your mind is going to be going, oh, I don't get this. What if I do this? And this is this. Okay. So your mind will have imprinted on it a kind of an alternate version of that digit, which goes back to when you were learning it and you were confused. So what we then have to do is to give the mind an opportunity to reframe its experience of that stimulus. So two things then help. First of all, we've got not just the digit, but we've got the meaning here as well, right? By this point in the Davis process, the person we're working with has a set of mental self-management tools, collectively known as orientation, that I was talking about earlier, that you can use in order to switch off the disorientation. Those tools will also tell you when you're being disorientated. So somebody working through this process, first of all, they would have a strip in front of them so that they would be able, in an orientated state, to check the numerals and get them the right way round, in a kind of a state of stable focus, if you like. Then we have a process of going through, looking, touching, saying 0, 1, 2, 3, 4, 5. What? Oh, on 5, I disorientated. And I can feel that because my mental tools shifted. and you've trained me in feeling that. Okay, whoa, okay, I disorientated. So then we could go, right, okay, fine. Get your orientation back. Pull this forward. Let's take a look at it. Yeah, describe the shape. Yeah, which way round does it go? Okay, how many curly bits are there? How many straight bits? Yeah. Check tools, take a look again. 5. Okay, and so on. And then this process then ends with the person making a clear set of mental images, so closing their eyes and picturing what they've created so that they can name what they've created forwards and backwards. So the combination of making it in clay and using the Davis tools gets a person to a point where they now have a stable, one good stable mental image for what these things are. Okay, I don't know, Axel or Marta, if you want to add anything to that, or if we're good on that.
Well, I could just mention, which is kind of obvious from everything you've said, that in order to kind of attach new information into your existing knowledge, which is what learning is about, these children or even adults, they need the meaning. They anchor it into the meaning more than the shape or the sound. So each numeral has a name, like 5, and it has a shape, but it also has a meaning, and it's the meaning that is attached to the long-term memory.
Yeah, absolutely. The other thing that can affect digit reversals is confusion around left and right. And I don't probably have the time to go into this here, but we have a tailored approach in Davis as well, using the clay that will resolve left and right confusions and, create certainty there. So that sometimes is an element in it as well. We have another question. Thank you for this evening. Could you say something about the difference between dyscalculia and an ADHD math difficulty? How can I tell the difference? And is the intervention the same or different? Yeah, that's a really interesting question. So it's kind of both. It's the same and slightly different at the same time. If I just go back to the hierarchy of difficulties that we looked at earlier, yeah, you can probably see from here where ADHD would sit in this hierarchy. It's focus, right? If your focus is non-linear, which is essentially, a key element of ADHD, you're going, your thinking is going off in tangents all the time. Okay, then you're going to find it very difficult to resolve a sequential mathematical problem because you have to maintain your thinking on the same thing from start to finish. Okay, that's also going to affect your mathematical thinking, but actually rather more than that. If you have an ADHD difficulty, you will have difficulty with the idea of cause and effect. That will at some level be incomplete because that is why you are impulsive. You will also most likely have difficulty with time, and you will have difficulty with sequencing things, which is again part of what makes you impulsive, what makes you get stuck in unpleasant situations again and again, because you can't use the thinking tools of cause, effect, time, and sequence and order in order to figure out, oh, how did I end up here? Yeah. In this sticky situation, or what can I do next time that would produce a different outcome? Okay, so those same concepts that we were looking at in a mathematical context, these ones, okay, they also lie at the heart of difficulties with ADHD. Now, beyond that, then it's a question of whether it's just this, okay, and then once these are put in place, the rest is going to be fine, okay? So essentially what you've got is not a maths problem, but a glitchy focus and a lack of mastery of sequential thinking, okay? Or whether these are also going to need, sort of tailored multisensory work. When there's a significant ADHD difficulty with ADHD, we would probably spend longer down here. We would have a much more richly explorative process in order to make sure these really become part of where are they gone? Here we go. These concepts really become part of a person's identity in a way that they haven't been up till now. Okay, so I hope that's enough of an answer to that one. Who diagnoses dyscalculia? An educational psychologist. That's a really good question. In the UK, educational psychologists some will diagnose dyscalculia. Also, some specialist teacher assessors who have undergone additional fairly extensive training in order to be able to diagnose dyscalculia. They are fairly few and far between. It is not easy to get a diagnosis of dyscalculia in the UK. A good starting point would be the SASC website, SASC, where you can look up assessors, but you may have to go through and kind of contact them one by one. Okay. So another one, my son just completed the Davis program, dyslexia correction and attention mastery. He's also diagnosed with dyscalculia. Should we finish mastering all the trigger words and doing the post-program work before embarking on a maths mastery program? In my experience, not necessarily. However, if your son has just completed attention mastery, you might just want to wait a little while until you feel that the concepts mastered in the attention mastery program have had time to really embed into your child's identity. So it may be, waiting a couple of months or so, staying in touch with your facilitator, using some of the post-program time to discuss, your facilitator's view of, based on how your child's developing, whether they think they're ready. That would be, I think, important. Not necessarily mastering all the trigger words before you embark on maths. That would be my opinion. Again, Axel and Marta, do you have anything to add to that?
No, I agree with you, and I just wanted to kind of touch on a question that came earlier, which is the link between ADHD and maths, that you can have an individual that struggles with both ADHD and maths, but you can equally have an individual who is excellent at maths and struggles with ADHD.
Yeah.
And and it's interesting because they are both maths problems and ADHD problems share a common root, but within maths, once you understand the operations and so on, then it's a very simple consequence that you're looking at in maths. But in life, the consequences, there are so many variables in life that they can be much harder to navigate.
Yeah. Thanks, Axel. So we've got another question. I'm still waiting for a dyscalculia assessment for my son. If he is dyscalculic, will he be entitled to any additional support at school, or will the teaching likely stay the same? I know how strapped schools are for specialist resources. What I'm trying to get at is, would a diagnosis actually make any difference to his school experience? Well, that's a really good question. There's a lot of variables in there, not least how is the SEN support at your child's school? How enlightened is the teaching? In the UK, it's the classroom teachers who have the primary responsibility for supporting SEN in the classroom. Okay, but their support for SEN is only going to be as good as their understanding of what SEN is. And in my experience, I did my teacher training 12 years ago. And the teacher training I received, the SEN training was very superficial. It was an hour and a half, a PowerPoint over an hour. So it's like this webinar, pretty much, was my SEN training as a teacher. Okay. So therefore, how aware a teacher is of SEN is going to depend on the school, the leadership team, the Senko, how much emphasis is placed on SEN, in-house CPD, ongoing professional development training for the teachers, and or how curious the teacher is, that's kind of the reality of the situation. And you rightly say that schools are strapped for specialist resources. So schools are, somebody trying to support SEN in a school as a Senko is not doing an easy job. If they're doing it well, they're doing it well as a result of Herculean efforts. Okay. Therefore, that's not going to happen everywhere. So that's kind of one side of your question. Will this teaching likely stay the same? It's really difficult to say. It just depends on, the realities inside the school. What would be, what will help you will be to stay in close contact with your Senko, and to request regular meetings and to find out, what assessing, planning, reviewing, further action plans are kind of being developed for your child as you go along. But you have to be pragmatic about it. In terms of being entitled to any additional support, the support that you wouldn't automatically get additional support based on having a dyscalculia diagnosis. So if we're thinking of things like exam access arrangements, reasonable adjustments in the classroom, extra time, things like that, those will be based on cognitive scores that you would get from any diagnostic assessment, including a dyslexia assessment, and or from internal testing that the Senko can do in the school. So it's a complicated area with a lot of variables, but essentially, from a Davis perspective, we can help. So you can go down the assessment route, or you can ask for support from the school. But if what you want is a systematic, step-by-step, simple building one after another of mathematical ability and competence, then that's what a Davis program will do, and it will do it really fast. Okay, so you can hit lucky in a school situation, but it's likely that what you'll get from the school will have to be a bit piecemeal, because the teacher isn't just teaching your child, and they're strapped for resources, and there's limitations on the awareness of what SEN is, and dyscalculia out of all the SENs is the least understood in most situations. So I hope I'm not painting a depressing picture, but the nice side of it is that, there's a lot that we can do to help. Okay. Next question: if a parent is dyslexic, is it more likely the child has dyscalculia, especially if both have huge issues with time? Issues with time. So two things here. Issues with time very often do go hand in hand with dyscalculia. Okay. It's not automatic, but pretty much every individual I've worked with who had maths difficulties had difficulties with time. Most individuals who struggle with time also have maths difficulties at some level. And what we also know is that learning differences do tend to be hereditary, as do a lot of other, thinking styles. It's not we're saying that a disability is hereditary. It's that many thinking strengths are hereditary. So my mother was a director of music. I'm a good amateur musician. My sister is a peripatetic music teacher. My niece and nephew are both musical. All my children are musical. My eldest son is a junior conductor. These things do run, in a hereditary way, and so does picture thinking, and so do learning differences. Okay, so it is quite possible. Okay. I've got another question. I've been teaching for 12 years and I'm the only one on my staff who knows anything about Davis. Tell me about it. I only learned about Davis because my son was diagnosed with dyslexia. Well, I'm glad that you did. There's a lot of work going on in the Davis world at the moment, of which this webinar is part, to really try and get the word out now as to who we are and what we can do. Thanks for that. I'm training to be a dyscalculia tutor, so I already have tools to make maths visual. How could the Davis method assist me in helping students further? Well, really in the hierarchy of what we've been looking at, okay? So going back to that slide where it's not just about visual tools for mathematics, it's about what's going on beneath the surface before you even get to the mathematics, okay? So it's working up through this hierarchy. And these two bottom layers in particular, this is where Davis really specializes. Okay, it's in mental tools that give you control of your focus from start to finish of a task. And then these concepts that make up mathematical thinking: change, consequence, time, sequence, order, disorder, and the way that we build these out using the plasticine. And the other element in Davis is that we're not making teaching visual is great. Giving a child the resources that they need in order to create their own materials that teach themselves is even more powerful. Okay, and so that's what Always Davis is about. It's about actively employing the learner's own creativity in the task of resolving what's going on. But the fact that you are already visual is already great. That's already more than 50% of the way to to what's needed, most definitely. Okay, what about adults with learning differences? Can the Davis method be provided as part of an access support, reasonable adjustments in the classroom and/or workplace? Government-funded programs such as Access to Work. Yes, I have worked with an individual on Access to Work. It is a mountain of paperwork. We might need, do contact one of our facilitators, and it is an area where, we are able to draw on some expertise in order to, attempt to get that funding. But certainly I have successfully had Access to Work funding in the past. The oldest person I ever worked with on a Davis program was 85. We very much work with adults. I had a very powerful maths program a few years ago with a 30-year-old woman. It's very much, adults are very much part of what we do. Do you conduct assessments to determine specific issues that need to be addressed? So we don't, in Davis, we're not diagnosticians. We don't conduct diagnostic assessments. We do have an initial intake program assessment in which we attempt to nail things down to the specific goals and aspirations that the person wants us to help them with. Is a 45-year-old too old to benefit from dyscalculia remedying? Absolutely not. No, by no means. We very much work with adults. Okay, so thank you all for this abundance of questions, which has been really great. We're going to cross over to we've got another one coming. I'm working with twins, one with dyscalculia, doing the Davis method. Can both do it together? Whoa, you're in unknown territory there. As facilitators, we don't work with a group at the same time. So it's not to say it wouldn't work, but it would be experimental in the context of what we're doing. The challenge that you would have would be that that even if they're both dyscalculic, they won't be dyscalculic in exactly the same way. Each will have their own individual triggers, learning challenges. So that's where one-to-one is certainly the most powerful means to address what's going on. It doesn't mean that you couldn't help, but it would be experimental. Okay, so we're going to cross over to the other side now. Ooh, sounds mysterious. But as I indicated at the beginning, we're going to, we've had longer in the webinar than I thought we were going to because of all of the questions. Oh, a couple of things actually. We've got, thanks for your feedback for sending that in. 6th of June. Oh, that's interesting. We've got the wrong thing up there. If you bear with me for a moment, I will show you what we're doing on the 6th of June. Sorry, this will just be one moment. We're going to do another webinar where we're going to be going back to the topic of dyslexia. And here is what we're going to do. Are you seeing this okay? We're going to be looking at how dyslexia works, unraveling the mystery of a learning difference so reading can be easy. So we're switching focus over to our dyslexia program, in particular with a focus on reading. Okay, what has been making reading difficult for an individual up to this point and how we can make that easy. Okay, that you will find, in fact, I can probably send you a link for that. Oh, I'm sorry, this is so frustrating. Oh yeah, I got it now. Okay, I'm just going to drop a link into the chat so that you can see if you want to get ahead and get a place on that webinar now, then you can follow that link in order to be the first person to get your place on it. So that's going to be in another 3 weeks' time. Looking forward very much to perhaps seeing you there. And I'm now going to open up the coffee meeting. Okay, so I'm going to once again drop into the chat the link to that. So sorry, I'm all fingers and thumbs now. But if I can just get this here. Great. So into the chat now is going one more time the link to the coffee meeting. Okay, just going to check that link's working. Yes, it is. Okay, so just make sure if you want to come to the coffee meeting with us that you click on that link now. So the bottom link in the chat that says coffee meeting. Okay, click on that link so that it opens up the page, because when I close the webinar, all of that will disappear. Okay, and if you want to join the coffee meeting, you're going to need that link. If anyone is clicking on that link and not getting there, then just type help or something into the chat, okay, so that we know you're struggling. Otherwise, if you've all got that link that's in the bottom of the chat, then in a moment I'll close the webinar. We'll open the meeting via that link, and we'll see you if you want to join us on the other side.
There's
Axel.
another question in the Q&A, apparently.
Okay. How could I train my apprentice in construction maths using Davis? Now, that might be something to bring into the coffee meeting, to be honest. That's a nutty question. I mean, not in the sense of needs to be nutted out. If you're able to join us in the coffee meeting, we can perhaps drill down a little bit into what that is. Okay, we've got a hand up. Okay, I've allowed you to talk.